Good morning, class. I hope you all are staying healthy and at home and good. So, let's start with today's lecture. In yesterday's lecture, we were discussing encryption decryption. We were on conventional method, means public, the encryption key and the decryption key are the same, and encryption and decryption algorithm are reverse of each other. In conventional method, we discuss character level, bit level. In the last lecture, we discussed bit level encryption, in which we discussed various operations using which you can do bit level encryption like product, S box, permutation, P box, XOR, substitution. These were the things which we discussed in detail in the last lecture. In today's lecture, we'll be discussing a algorithm bit level based encryption example. This is encryption technique widely used for bit level encryption. The algorithm is data encryption standard, popularly known as DES. DES, DES. This is a encryption algorithm developed by IBM, and it was used by US government for sending their data widely, which was important data. They used DES algorithm for the encryption. Let us study in detail what is DES algorithm. It encrypts a 64-bit plain text using a 56-bit key. What do I mean by this is that it is a bit level encryption. That means a plain text, it can be any a document, a text, an audio, a video. You divide that into bits, block of bits of 64-bit each. That will be the plain text to be sent. You use a key, your encryption decryption key, which is 56-bit long for encrypting the data. The text is put through different stages. We take total 19 stages through which it will pass, and these are the very complex stages. 64-bit plain text is sent and 64-bit cipher text is being received. Let us have a look on the DES steps. These are the steps. This is a plain text, 64-bit plain text, and you receive a 64-bit cipher text. You use a key of 56 bits. We'll study these steps in detail, but for now you can see that there are 19 steps in between, numbered from 1 to 19. The first and the last step is very simple transposition, that you are only changing the position of the bits of the plain text. The steps from 2 to 17 steps are complex step. On the next page we'll discuss the detailed structure of this complex procedure. These are the combinations of substitution, XOR, rotation, transposition, all the functions we have discussed in the last lecture, bit level encryption. The combination of these operations are used in this 2 to 17 step, which is the complex step. At step 18, you are doing the swapping. You are only swapping the bits with each other. So at each and every these 2 to 17 step, you use a key which is 48 bits. The 48-bit key is generated using this one key, 56-bit key, which is being shared between the sender and the receiver for the encryption and the decryption. It will get more clear as we see in detail these steps. Let's first look at the steps, the procedures to generate the key. As I have told you, we use 156-bit key, encryption key, decryption key. You generate 48-bit key for each and every step. This key is different for all the steps from 2 to 17. What you do is the 56-bit key is divided into two, 28 bit each. 28 plus 28 is 56. So you divide it into two parts. You perform it separate rotate function on this 28 bit and rotate function on this 28 bit. So after rotating the bits, you will get a rotated 28 bit set here, 28 bit set here. You will combine them back and you will receive the 56 bit again. Then you apply a compressed permutation on it. You will compress it in such a way that you will get 48-bit key. What is compressed permutation? As I told you earlier also, permutation is that you are changing the position of the bits. Permutation we discuss three types: simple, compressed and expanded. In expanded, you are increasing the number of bits of the plain text. In compress, you are compressing the bits. So I have reduced the bits from 56 to 48. Now this 48 bit key generated here will be used for one of the step. Then for another step you will use the same function again, and you will receive another 48 bit key, right? In this way you are generating sub keys for different steps of the DES. Clear? Now let's have a look on these steps which I have written as complex in the previous diagram. We will study it in detail that what are these diagrams. Yes, this is one of the step of the 16 from 2 to 17. What we are doing is it here. It is an iterative method. What do I mean by iterative? That the data from the previous step is used. You can again have a look on the diagram here. This is the input for the first stage, plain text. You apply the transposition. The output of this first stage is put as the input for this second stage. You will perform the first complex procedure, which we will shortly discuss. The output of this short complex procedure will be the input for the third. That means it is iterative. The output of the previous is used as input to the next, right? Now coming on this complex procedure, let's discuss the structure of it. The step 2 is that the output from the previous, that means after applying the transposition, the 64-bit data after transposition, what you will do is you will perform first divide function. What divide do? It divides into two equal parts. 32-bit plus 32-bit is 64, so it is divided into two 32-bit parts. Left part I am not touching, it is as it is. We are performing some of the operations on the right part. What you are doing is first you perform expanded permutation. That means you are increasing number of bits by changing the position to 48 bits. Why I have done it 48 bits? Because my plain text was of 64 bit and my sub key is of 48 bits. So I want it to convert to 48 bits so that 48 plus 48 can be some of the operations can be performed together. 48 bits are now received after expansion. You perform XOR function with your sub key kn, means at each and every process in this step you are generating a sub key. In first step you receive K1, in second step you receive K2, K3, so on till 17th step you are receiving the sub key. So the sub key generation, the K1 will be XORed with this 48 bit and you will receive a 48 bit data. XOR function we discussed yesterday, same thing will be done here. Now you perform compress permutation. Why compress? Because again you want to convert it to 32 bits. अभी आपने इसको 48 में convert कर दिया था, पर अब आप इसको वापस 32 में करोगे तो you are doing compress permutation. 32 पे फिर simple permutation लगाई और एक 32 bit का आपके पास set आ गया. This all we have done on this right part. Now you will do XOR with this left data जो अभी हमने change नहीं किया, it is unchanged. जो इसको XOR करके आपको मिलेगा 32 बिट आपका राइट पार्ट हो गया. And here in this arrow you can see this right part without performing any operation is directly taken as your left part. Now this left and right part will be combined together and you will receive a 64-bit data, right? In this manner, this is a 64-bit data received from the previous step is converted in by passing through this complex procedure, and this output will pass to the next complex procedure. How? What I am saying is, यहाँ पे अभी हमारे पास ट्रांसपोजिशन हुआ था, हमने फर्स्ट स्टेप कॉम्प्लेक्स प्रोसीजर उस पर किया, 64 डेटा मिल गया हमें. अब ये फिर से सेम साइकिल रिपीट होगी इस 64 बिट डेटा के साथ विद द सब की K2 of 48 bits, right? This is how guys we are doing this DES algorithm. डिक्रिप्शन के टाइम पे यही सारा रिवर्स मिल जाएगा. अगेन की सेम यूज होगी 56 बिट की एंड सब जनरेशन ऑफ द कीज विल बी डन. थैंक यू क्लास. इन द नेक्स्ट क्लास वी विल बी डिस्कसिंग पब्लिक की मेथड. अभी तक हमने इंक्रिप्शन में सिर्फ कन्वेंशनल मेथड करे हैं जिसमें पब्लिक इंक्रिप्शन एंड डिक्रिप्शन की आर द सेम. In the next lecture we will discuss public key methods in which the encryption decryption keys are different. Thank you for today.